Hello students, today we shall have a session on numerical and statistical methods. This is a lab program and the title of the program is Program to Construct Discrete Frequency Distribution Table and Find Mean and Standard Deviation. So before I go to the program, let me understand how this program will work manually. So here I need two inputs of n values. So I'll be inputting this to two arrays called as x and f in this manner. So I have an array x and my input values are 10, 20, 30, 40, 50. This means 10 is stored to x of 0, x of and 20 is stored to x of 1, 30 is stored to x of 2, 40 is stored to x of 3 and 50 is stored to x of 4. Similarly, I have one more array called as f. In f of 0, 2 is stored, f of 1, 3 is stored, f of 2, 4 is stored, f of 3, 5 is stored and f of 4, 6 is stored. Then each of these values are totaled and stored to the respective variables called as x sum and f. You can see the value of x sum is 150 and the value of sf is 20. Soon after this, we need to calculate f into x called as fx as shown here. So what is fx? 10 into 2, 20, 20 into 3, 60, 30 into 4, 120, 40 into 5, 200, 50 into 6, 300. Again, these values are totaled and stored to sfx and that total value is 700 because here. Next we need to find the square of each values of x called as x2. You can see here 10 square 100, 20 square 400, 30 square 300, 40 square 1600, 50 square 2500. The total of this is 5500. This total is stored to the variable name x2 sum. After this, the value of x and the value of x2 is totaled in this manner. You can see here 2 into 100, 200, 3 into 400, 1200, 4 into 900, 3600, 5 into 1600, 8000, and 6 into 2500 is 15,000. Now these values are again totaled and stored to the variable name sfx2 and the total value is 28,000. Now the next step is to find the mean. How to find the mean? sfx divided by sf. You can see it. sfx divided by sf. What is the sfx? 700. What is the sf? 20. So what is the total? 35. So 35 is the mean of this distribution table. The next step is to find the standard deviation. So the formula to find the standard deviation is square root of sfx2 divided by sf minus power of m comma 2. So let me understand what is this sfx2 divided by sf. sfx2 is this one, 28,000. You can see. Divided by sf is what? 20. So sfx2, that is 28,000 divided by 20 is 1,400. Now let me see what is the value of power of mean comma 2. What is mean? 35. 35 raised to 2 is 1225. So from 1,400, 1225 is subtracted. The resultant value is 175. Now the square root of 175 is found out, which is nothing but 13.22. This is how the program works. So let us understand in detail how the program has been done. So before I start the program, let us understand what all variables are essential. I need a variable I need a variable n. N is to find out how many values I have to input. Like here you can see there are 5 values. Similarly, I may input 6 values or I may input 10 values. To store these limit, I need a variable name n. Now, I must count from 1 to n. So for that, I need one more variable name I. Further, I need 5 arrays x, f, fx, x2, fx2. Right? Similarly, I need variables to store the total of x, the variable to store the total of frequency f, then fx, then total of x2, total of fx2. Further, I need a variable name mean and standard deviation. So let us proceed. Firstly, hash include stdio.h, my header file. Hash include conio.h. These are the common header files. But since I'll be using power and square root, I'll be using a header file called as math.h. Okay, this was about the header file. Now coming to the main function, void main, open flower bracket and closing flower bracket. Open flower bracket indicates the beginning of the main function. Closing flower bracket indicates the end of the main function. Inside this, I need to declare the variables that we have just now discussed. So here we are. Int I, comma, n. These are two variables. Then again, array starts, comma, x of 20, comma, f of 20, comma, fx of 20, comma, d of 20, comma, ds of 20, comma, fd of 20, x sum, sf, so on. Then mean, standard deviation. So these are the variables. So the first line, CLR SCR, this indicates clear the screen. So the first statement here, printf, enter total number of elements. So this message is prompted on the screen to the user telling that how many elements do you want to enter? How many values do you want to enter? Whatever is the value, that value will be stored to n. So let me assume I've taken the value 5. That means I want to add 5 different numbers. So that 5 will be stored to the variable name n. Okay. Now I need to take a loop as a counter from I to n. So I have taken loop for I equal to 0, I is less than n, I plus plus. Instead of taking I equal to 1, I have taken I equal to 0 because the array index in C begins with 0. So I have taken I equal to 0, then I is less than n. So this is the opening of this for loop and this is the closing of the for loop. Inside this opening closing bracket, I'll write a statement to input the values in x and f. Here we are. Printf, enter the value of f, x and f altogether. So here I've taken scanf, %d, and x of I and f of I. So first time the value of I is what? 0. Suppose if I enter the value 10, the first value 10 will be stored to x of I, that is x of 0. You can see it here. So in x of 0, what is stored? 10 is stored. Similarly, the second value I will be entering is 2, for example. So that 2 will be stored to f of I, that is f of 0. So here we are, f of 0. So this loop goes back to the loop. As it goes back to the loop, the value of I will increase. I will be 1. It will come and check here. Is I less than n? Yes. 1 is less than 5. Comes down. Again it asks you enter the value of x and f. So again I may give 20 and 3. This 20 will be stored to an array x of I, that is x of 1. Here we are, x of 1. And the value 3 will be stored to f of 1. Here we are, f of 1. Again goes back to the loop. So this way 5 times I'll be entering the values, which may be 10, 20, 30, 40, 50 in x, 2, 3, 4, 5, 6 in f. Now I need to total these values. This value I want to total as well as this value I want to total. Okay. Now the statement goes like this. X sum is equal to X sum plus X of 5. So if I assume that the value of Xi is 0, so X sum, what is the value of X sum? 0. 0 is equal to 0 plus X of I, that is S of 0. What is X of 0? 10. 0 plus 10, in X sum what is stored? 10 is stored. Similarly, SF, what is the initial value? Initial value of SF is 0. 0 is equal to 0 plus F of I. What is F of I? F of 0. What is F of 0? 2. So what is the value of SF? 2 for time being. Goes back to the loop. Then next time the value of S sum will be nothing but 10 is equal to 10 plus X of I, that is X of 1. And what is X of 1? 20. 10 plus 20, in here 30 is stored. Similarly, SF is equal to SF plus F of I. What is the previous value of SF? 2. 2 is equal to 2 plus F of I, that is F of 2. What is F of, F of 1? What is F of 1? 3. So 2 plus 3, 5. Again it goes back, so on. At last we get the total here as what? 150, it is stored to X sum, and this 20 is stored to SF. Once this is over, I need to find Fx. Let me proceed. Fx of I is equal to, that is Fx of 0 is equal to X of I, that is X of 0 into F of 0. X of 0 is what? 10. F of 0 is what? 2. 10 into 2 is what? 20. That 20 is stored to X of I, that is X of 0. So here it is. Then X2 of I is equal to X of I into X of I. What is X of I? X of 0. 10 into same value 10. So here we have got 20. Sorry, we have got 100. You can see it. That is over. X2 of Fx2 of I is equal to F of I, that is frequency, into X2 of I, that is 100. So 2 into 100, how much we got here? We got it 200. Goes back to the loop again. Same process continues. So next time you can see here Fx. What is Fx of I? Fx of 1 is equal to X of 1 into F of 1. What is X of 1? X of 1 is 20. What is F of 1? F of 1 is 3. 20 into 3 is how much? 60. Got it here. Then coming to X2. X2 of 1 is equal to X of I, X of 1 into X of 1. What is X of 1? 20. 20 into 20, here we got. How much? 400. F2 of I is equal to F of I, that is what? 3 into X2 of I, that is what? 4. How much it is? 1200. Again goes back. So on. In this way, this all thing is calculated. So it is stored in those two arrays. Now I need to total what? Fx, x2 and fx2. Here it is. Sfx is equal to Sfx plus Fx of I. So what is Sfx initially? 0. 0 equals 0 plus Fx of I, 20. 0 plus 20 is 20. Then Sx2 is equal to Sx2 plus x2 of y. The initial value of Sx2 is 0. 0 plus x2 of y. x2 of y is what? 100. 0 plus 100? 100. Yes, fx2 is equal to sfx2 plus fx2 of y. Initial value of sfx2 is 0. 0 plus f200 is 200. Goes by the loop. This again proceeds again. So same way what happens is the values of fx is be found out, which is 700, and it is stored to s of x. You can see here. Similarly, all the values of x2 is added to sx2, and the value is 5500. Similarly, fx2 is been added to sfx2. Now the next part is mean. What does it mean? Sfx divided by sf. What is sfx here? You can see 700 divided by sf. What is f? Sf 20. So how much you got here? 700 divided by 20 is 35. Now next line. STD DEV is equal to, that is standard deviation, is equal to square root of SFX2 divided by SF. That is nothing but 28,000 divided by 20, which is nothing but 1,400, minus power of mean, that is 35 comma 2, that is 1224. So from 1,400, 1224 is subtracted and the resultant value is 175. Square root of 175 is 13.22. So this 13.22 is stored to this standard deviation. So till here, it has been stored to an array and a variable name. Now we need to show the output on the computer screen. So you can see here printf x slash t f slash t fx slash t x2 slash t fx2 slash l. So when this line is executed on a computer screen, this is shown like this. This is the output on a computer screen. Now below this, all the values of x, f, fx, x2, fx2 should be displayed. So for that, what I need is, I need a loop. I need a loop from 0 to n. So here it is. For I equal to 0, I less than n, I plus plus. Okay, value of I is 0. Printf. First what? X of I. What is x of I? X of 0. What was x of 0? 10. Then f of I, that is f of 0. F of 0 was what? 2. Let me see. You can see here 10, 20, 2, 20, 100, 200 has been printed. Again goes by the loop. Again when it goes by the loop, the next value is printed. You can see on the screen 20, 3, 60, 400, 1200. This process goes on till all the values are printed on the computer screen. And at last, mean is equal to 35.00 is shown here. Standard deviation is equal to 13.22. This is the program output. Okay, this is the end of the program. Thanks for watching. Let's meet in the next video for more statistical programs. Please like, share and subscribe my video so that I can create more interactive videos for you. Thank you.